Hi everyone. Today we will see about multi-layer perceptron. Perceptron is nothing but a simple binary classification. Whether it has provided the output either 1 or 0, a yes or no. It functions mainly as a part of human brain. So the neuron has the ability to learn and solve more complex problems. Diagram for a perceptron. So here these are all the inputs and these are the corresponding weights. You have to product the inputs and their corresponding weights, and all of them are summation together, and we can get the output either as 0 or 1. So the main types of neuron are single layer and multi-layer. So here in single layer, that's only one hidden layer and output layer. So in case of multi-layer, they are having many number of hidden layers. So the types of perceptron model, single layer perceptron model, it consists of a feed forward network that moves from left to right. So it can learn only linearly separable patterns. That's the main function of this single layer perceptron model. But here it is similar to that previous single layer perceptron, but it contains more hidden layers. So forward stage is from input hidden layer and to output. Third stage we calculated the error function. So after that we moved from right to left, which means that from output layer then to hidden and then adjusting the weight layer and input layer. Advantages and disadvantages. A multi-layer perceptron normally it solves non-linear problems. It works well with both small and large amount of data, and it makes the predictions quickly. The same accuracy ratio even with the small or large data set. Drawback is that it is a time consuming and complexity one. Difficult to predict how much dependent variables affect those independent ones. Depends on the how much amount of quality training is be provided. The characters involved in a perceptron model is that uses a maximum supervised learning of weight coefficient is always learned automatically. Once we multiply the weight with the input features, then the decision is made automatically. Activation function is then applied, and it's enabling the distinction between two linearly separable classes normally with +1 and -1. All the values are sum up together and it have an output signal, or otherwise there will be a no output. The limitations perceptron model is that it can be only a binary number. So it can able to classify only as a binary classification rule, and also classify the linearly separable set of input vectors. Multi-layer perceptron. So in case of multi-layer perceptron, it has various applications like recognizing the speech, translation of machine languages, then complex classification task for large data sets. Here the main operation for MLP is that it utilizes the bidirectional propagation, which means that both forward and backward, and we can adjust the weight during that backward propagation, and with the help of activation function we can enhance the network capability. So advantages of this MLP is mainly it used in case of deep learning algorithms, but the drawback is that the design is very complex and sometimes the processing is very slow. Each and every input layer is connected with the hidden layers, and final output is provided. While using this type of MLP, when other activation functions are used, which results mainly in the values between 0 and 1, or else between -1 and 1. So the first step is backpropagation. So here to obtain a better weights, to get a improvement in their weight so that the neuron can learn many things, calculating the error function, then updating the weight from backward region. Algorithms to fine tune the weights, the most common one is this backpropagation. We are adding that bias factor. So then activation function. So among the several activation functions, we are using a sigmoid activation function. For an example, if you are having input values in between the range of 1 and 100, output could always be 0 or 1. So finally the output is normally a classification decision. So the output of the one layer perceptron is input to the next layer. Transformation. So always we are working with various multi-layer perceptrons, and moreover the neural networks are essentially the same thing. So there are we called backpropagation hyperparameters and more advanced in their structures. So during that backward pass only we are going to tune the weights of all the inputs. We are tuning the weight of the inputs. So actually this is the input layer, hidden layer, and this is the output layer. The loss function is calculated, and from that layer we are going to adjust the weight. For example, this is W5, W6 and then W7. So these is the weight combinations that we have to adjust from the backwards. So this is Y1 means this is output of Y1, which is that sigmoid activation value. So with the help of the derivative functions, we adjusting the weights. So after adjusting the weights that between the hidden layer and output layer, then we move towards this W1, W2, W3 and W4. So this is the weight that connect in between the input layer and hidden layer. So once we completed this weight means now we obtain the new weights. So what do you mean by a model and hyperparameters? Model parameters are internal to the neural network normally. For example, the weight of the neuron. So they automatically extracted from the training samples to make the prediction. But hyperparameters are some external parameters. Actually, this one is internal and this one is external parameters. Selecting which activation function suit us for that algorithm and the batch size that we are going to use during the training. These are some hyperparameters: the total number of hidden layers, dropout, then the activation function, the initialization weights. So during the training of the algorithm, the learning rate of the neural network, the iterations, the epochs and batch size, and then which optimization algorithm that we are going to use, the learning rate. So how fast the backpropagation algorithm performs the grading descent to minimize the loss that we can find out. A lower learning rate can make the neural network training faster. Okay, so if we make the learning rate as low means that helps the network to train very fast. Normally that epochs is the number of iterations that we are using, the iterations, number of times that we are going to train the algorithms, size of the batch that we are using. So this is what we call overfitting. So we have to reduce this overfitting. Then find the optimal value, list out the error, then fitting rule. Optimization algorithm that we are using is the stochastic gradient descent. There are various tuning methods that we are used, hyperparameter tuning, grid search, random search and Bayesian optimization. The grid search, so based on some window based method we are searching. If you are having a total number of 10 to 100 samples means in a step of 20 we are searching. This is a random search, just random values presenting in that entire problem space. Here it provides a very high accuracy. We are comparing the grid search with the random search method. Here the data are splitting in a random manner, but in a grid it's arranged in a matrix format. In a Bayesian optimization, it trained the model with different possible hyperparameters values. So over the time it trained the values again and again. Some advanced structures compared to that convolutional neural network and recurrent neural network. Convolutional neural network is mainly used for image recognition. So it has some drawbacks that will be overcome by this recurrent neural network that depends on both the present and past inputs. And also we are having several libraries that we can use as TensorFlow, Keras, PyTorch. While we are implementing with this deep learning, we can have many advantages and because it's having many library function inbuilt with them. Thank you for watching the video. Meet you in the next video. Till then, it's goodbye from Vijay.